Today we're doing 10.2 using combinations and permutations. These are things that you might want to end up writing on index cards because you need to know the difference between combinations and permutations, because in problems they won't always tell you this is the combination problem. You just have to figure it out. And they won't always say it's a permutation problem. So the things with combinations is that order is not important. So that's what you need to remember with combinations. Order is not important. Where with permutations, order is very important. So basically part of the homework today is just practicing if you can figure out if it's a combination or a permutation. So we're going to kind of go through this. So with each one, we're going to say, because of the order on the paper, I'm going to say that with using our fingers, combination is 1 and permutation is 2. Okay? So that we can kind of see what you guys know and what you don't know. If you don't get it right, it's no big deal. Okay? We're just going to try to do this. So, determine if it's a combination or permutation. So for question number 1, do you think it is a combination where order is not important, or do you think it's a permutation where order is very important? True, true. So let's just say for a normal teacher like this classroom, do you think it matters where you sit? Yes. Or do you think it doesn't matter where you sit? Some of you think that it doesn't matter, but you're wrong. Okay, the answer is 2. It's a permutation. Order is very important. Your name, it is not a trick question, I promise. If you come in here, there is a seating chart. Your name has a spot on here where you are supposed to be sitting. That means order is important. Otherwise, I would not have names written down here, and you guys could do whatever you wanted. Although some of you do that anyways. Okay. Number 2. Finding the diagonal of a polygon. Polygon is just a figure, a sided figure. Okay? 1 is correct. It's a combination. It doesn't matter. Actually, in a polygon, if it's a regular polygon, all the diagonals are the same. Okay. Number 3. Well, you need to think about it. Maybe you don't know very much about sports, but normally, well, actually not normally, always, unless you're playing t-ball, but this says the Pittsburgh Pirates, there is like a batting order. They have your name on, actually even in t-ball, they have your name on a roster and who goes when. So 2 is correct. Permutation is correct. Order is very important. Coaches really think about who they're putting in what spots when you are doing your batting orders. Okay, number 4. 10 books on a library shelf. Very good. And again, if we can just show fingers so everybody can kind of think about it on their own. But 2 permutations is correct. Dewey Decimal. That's right, the Dewey Decimal System. Shh. Okay, so if you go into a library, they don't just like throw the books out there because then nobody could find anything. So there is a very specific order so that you can find things in a library. So order is very important. Okay. Number 5, a hand of 5 cards from a deck of 52 cards. So think about this. You are dealt a hand. Does it matter which one came first, second, third, fourth, and fifth? No. Good. So therefore, it's combination. Okay. A 7-person committee from your class. So 7 people are chosen to participate in a committee. Does it matter who's chosen first, second, third, fourth? No. So therefore, it is a combination. Good. Anytime you see committee, and you're going to see this a lot, committee is combination. Okay? Because when someone's on a committee, they're just on it. Order does not matter. Okay. Number 7, first, second, and third chairs from 6 clarinets in a band. Very good. Order is very important. Okay. 6 outfits chosen from 14 outfits to be modeled. For some of you,
they have us do it in a certain order. Yes, that is very important. If you very important. Be on a runway one day and see what happens.
I know.
What years are those? That doesn't go first.
Okay, wait, but this is, does it matter? Okay, so they have I know that outfits matter, but they've chosen the 6, right? Does it
matter who goes first, who goes out first?
like? Does it matter which outfit is first, second?
It's a very precise
Okay.
order.
Well, the book would say this is a combination, but I agree with you guys. If you know,
See, that's why I don't like these. Like these are very ambiguous. Like they can be
this right now is just helping you guys think. We're just working on thinking. Okay. All right. If you ever need to if you get something wrong and you want to argue it, that's okay with me. You can do that. Okay. So.
This is on video.
All right. Moving on. Definition of a combination. Again, remember, you have N and R, where N is the number of combinations, and this is R, taking R at a time, right? N is the number of objects, R is how many you're taking of the objects. Okay, so this one is one that you actually need to know the formula on. Because remember with permutations, we could just make our blanks and then put our numbers into our blanks. Combinations is a little different. Because combinations order doesn't matter, that means there is more possibilities. And we should not be talking right now, gentlemen. Thank you. Okay. R is how many objects you're taking from the group. Okay, so there's 5 total things that you can choose from, and they're only going to be choosing 2 of those 5. Right. Okay. All right, but you need to know this formula. So this is one of those formulas you need to remember. With permutations, you didn't have to remember that formula. Okay, so what this means is, if we're going to this problem right here, what is my N value here? 5. Okay, this is your N, this is your R. Okay? So, it's going to be 5 factorial divided by what is, and then what you're going to do is you're just going to subtract these. Instead of writing it down like subtracting, I'm just going to subtract them. You guys can do that in your head, I think. So what is 5 minus 2? 3, so we have 3 factorial, and then R again, 2 factorial. So, just to kind of talk about this again to hopefully help you remember it. The big number goes on the top, the small number goes on the bottom, and then you also have to subtract them. Okay. And actually, I said the opposite of what I meant to say just a minute ago. There's actually less with permutations because order is important, right? No. I'm saying... Anyways, okay, let me just be quiet. Let's just do this math right now. Okay, so on the top, what is it?
5, 4, 3, 2, 1.
Good. 5 times 4 times 3 times 2 times 1. On the bottom, what is it?
3, 2, 1, 2, 1.
Okay, so 3 times 2 times 1 and 2 times 1. Okay, 1s do not matter, so I'm just going to go ahead and go through and cancel out all my 1s. Okay, then I have a 2, cancel with this 2. Then this 3 cancels with this 3. This 2 goes into 4 how many times? 2 times. So remember what I said about circling what's left over? I have a 2 left over and a 5 left over, and I multiply that together, and how many do I have? 10. Question? Okay, so what's your question on the next one? Number 2.
When there's 2 numbers the same at the bottom, they can just cross out, right?
No.
Come up with the same number.
No. Okay, so when we write this one out, what is going on the top? 10. Okay, so the first number is on top. The second number is on the bottom, and then you also have to subtract them, and it's on the bottom. So 10 minus 5 is 5. Okay, 10 factorial and 5 factorial are not the same. Okay, so we're going to write it all out. But this is what I think I would use as a shortcut. So see how I know I'm going to end up canceling out from the 10, 5 down? Do you get what I'm saying? I normally write it like this. 10 times 9 times 8 times 7 times 6 times 5, and then go dot, dot, dot. Okay? On the bottom, I'm going to take one of these 5s and just write it as 5 dot, dot, dot. Because this is really 5, 4, 3, 2, 1, and this one is also 5, 4, 3, 2, 1. Correct? So if you want to write it all out, you can. I'm just lazy sometimes, so that's what I do. But I still have another 5 factorial, right? So I go 5 times 4 times 3 times 2 times 1. So when I go to cancel them out, my 5s and the dot, dot, dots cancel out. Okay? 1 doesn't mean anything, right? Then you can decide how you want to do it. I like to just try to cancel out as much as I can. So I'm like, 3 times 2 makes, so I'm going to cancel out my 3 and my 2 with my 6.
And then 5 and 10 and 4 and 8.
Good. 5 goes into 10 2 times. 4 goes into 8 2 times. Circle everything that's left over, and we multiply all those together, and what do we have? What do we have? 252 is correct. That's why it's important you go through and circle all of them, because sometimes you will leave some off. Okay. Number 3. Think you guys can do that one on your own? I actually think you can do it on your own. And when you answer, you can write on your whiteboards. I'll come around and check a couple of you. Okay. So the correct answer is 792, if that was the answer you got. On the top, what's going to be on the top? Oops. Okay, so I'm going to start by writing it out, though. So we have 12 factorial on the top. On the bottom, we have 7 factorial, and also 12 minus 7 is 5. Okay, so I'm going to write 12, 11, 10, 9, 8, 7, dot, dot, dot. Because 7's my larger number, so that's the one I'm doing with my dot, dot, dot. And then I still have 5, 4, 3, 2, 1. So when I go through here, my 7's and the dot, dot, dots cancel. 1 doesn't matter. 4 times 2 is 8. 3 goes into 9 3 times. 5 goes into 10 2 times. So I have 12, 11, 2, and 3 left over. And when you multiply all of those together, you get 792. You can have different numbers than me because maybe you canceled them out differently, but no matter what, we should end up with the same answer. Okay? Now, who remembers how we do when it has a P? Shortcut for the P. The shortcut for the P is, this means you have 4 spaces, 1, 2, 3, 4, and then we start with this number. So we would go 10 times 9 times 8 times 7. And we multiply that together, and we get 5,040. Questions? Okay.
Would you get the same answer if you did it the other way?
With combinations? No, combination permutations will be totally different answers. Okay. All right. What do you think we're going to do with 5 and 6?
You have 45 seconds.
Oh, thank you. We're going to stop.